Okay.
Okay. So first I did the was in.
Yep. I would do the same. So, Noah?
And then I did the word O. The,
Beta.
Yeah, that. Yeah. And then I did a O. And then
So 43 degrees with the theta.
A I did.
So it does say in the question, calculate the length of QR. So QR is this one. Okay. So X definitely, and that is your right, the A.
For H I did 5.
And H is 5.8 because it's the longest side.
And then I asked on this one.
So the opposite side here, that's opposite the angle. We don't need to find it, and we haven't been given it. We cross out no, which means up here we cross out
So
stop and Toa.
and then next I did C of that. A over A.
Yeah.
And then C of that. 40. I got 0.7. Reduce the line. And zeros. And then
So we timed by 5.8 and we timed by 5.8.
and then you will become 4.
And we say correct three significant figures. So you wrote 4.42.
No.
So your long answer was 4.2418, like that, yeah? So it becomes 4.24 is equal to x.
I'm just that efficient.
You start calling you Pythagoras.
No, do it. She asked for it.
Did we all agree? Yes. All right, gorgeous. So if we look here first, we have to give our answer to three significant figures. Now, to be able to round to three significant figures, how many significant figures do I need? 4. So actually, the minimum I need in my working out is 4. I don't really need many more than that. Right? So we could have quite happily stopped, so 4.2, well here, 0.7313. The 5, we might have rounded that up to a 4. Or you could have just gone, I'll just keep the 5 and go to 5 significant figures. That's fine as well, yeah? And then you go, right, I don't need any of those, and I would have just done it with that. But it is important, this is why I said it's a good question, that you don't cut it down to 0.7, for instance, and use one significant figure when the answer has to have 3. Yeah.
So, what happens if it's like, when it comes to narrowing it down to the significant figures and you have to round up? What if the one behind that one makes the other one round up, then will the one in front of it round up as well?
Another very good question. Does anyone remember what we did before? So, let me give you a common one to check that. Did you all hear the question? So, for instance, if I've got a number like 2.8 999. And I want to round that number to 3 significant figures. Yeah? So I've got my first, my second, my third. So I cut there, but this 9 means we round up. So that would mean that this number would be rounded up. But what happens then?
It makes it a big number.
So it would make it a 10, wouldn't it? But what would a 10 in this column actually do? The next one would have 1 added to it. So this would actually become 2.90. Good. And we have to put the 0 because we need 3 significant figures.
Okay, but what happens if that same
So what if we have 9.999? 3 significant figures. The 9 rounds that one, which rounds that one, which rounds that one. So it becomes 10.0.
Okay.
So with significant figures, because this here, this is called, right? This is the required accuracy. So we've talked about this before, and I talk it all the time. The accuracy of an answer is not whether it's right or wrong. The accuracy is how many decimal places or how many significant figures we want. So if I round this number to 10, I've reduced the accuracy. It's still correct, but it's less accurate. All right. So, sorry, I lost track. That's what we were talking about. So, no, so what I was saying is, if the required accuracy is 3 significant figures, if we only have 2, then we have to put a 0 to mark, well, to this accuracy, it's a 0. Yeah? Make sense? Yeah. All right. What about the rest of you? Any questions along that? Understood what we were just talking about? Yeah. Okay. Do you want another one of those to practice, or are we ready to move on to the next thing? Okay, so I'll skip that one there, and that one. Right. This one is very similar, but at the end there is a different step. So it's not dramatically different, but there is something that we may well have to talk about at the end. But let's see if you can do it. So that is number 9. 9B. Let's see how far you go, because I what? Well, I'm just going to write out that I'm going to say sine of 32 degrees does equal 5 divided by x. Okay. Did we figure out what sine of 32 was already?
0.525.
Yeah, so we want 3 significant figures, so let's practice what we were talking about earlier. That's going to be 0.5299. Well, that's 4. The next one is a 1, so let's go around. Because it's opposite, it's always opposite divided by hypotenuse. It's not the number I don't know divided by the number I know. It's always opposite divided by hypotenuse. Okay? So sine theta is opposite divided by hypotenuse. That never changes. You just have to put in what you know. in the correct place. Okay. So we've now got this situation here. So I'm just going to rewrite it down here so I've got a bit of space, because this is where we're probably going to need to take another moment to think it through. So 0.5299 is equal to 5 that gets divided by x.
How do you know?
Okay, alright, I'll give you that. That's got a mathematical purpose, hasn't it? Got a reason behind it. Hang on, so let's talk about the difference between what Alistair just said and what you just said. So Alistair said, let's multiply by x. Okay? Why has he said that? Not because it's the hypotenuse now, but because it's, yeah, but it's because 5 divided by x, so timesing by x, makes sense. Now you might think that doesn't get me straight to the correct answer, but is it mathematically sound? Is it something you should do? Okay, so timesing by x gets rid of my divide by x. Now, before we write that down, let's just consider your option of dividing by 5. Why do we do that? What would that, yeah, what would that do for me? Okay, so you are correct actually. If I divide it by 5, this will actually end up being 1 over x. Alright? But that's not what you were going to write down, is it? You were going to write down that 5 divided by 5 gets rid of that and leaves me with an x, which is not abnormal. That's a very normal thing for people to do. But what does it forget? It forgets that this is not just an x. This is something divided by x. So not only are you now just eliminating the 5, you're now eliminating the fact that it was a divide by x. So that kind of had no real sound reasoning, does it? So that follows that path of if I divide, I cross out. And that's why we try and think a little bit more deep. Dividing by 5 would get rid of a times by 5. But we don't have that. What we actually have is a divide by x. And that's a problem to work with, but if I do times by x, I get rid of it, but what happens on this side? I have to times by x. Now I'm in a different situation, which I'm going to write x times 0.5299 is equal to 5. Now what would you do? No. So x times this gives me 5. So could I now do any kind of division? Well, if I divide by 5, okay, don't write this down. What do I get? 1. If I divide by 5 here, what do I get? Something super complicated, right? So does that make sense to do it? No. I could do it, it just doesn't make any sense to it, it doesn't help me. So let's not go down that route. What could I divide by? I want x, I want it on its own, I want x equals, so if this is a times 0.5299, 0, yeah, divide by that instead. Let's divide by 0.5299. On this side, we have to do 5 divided by 0.5299, and we get the answer 9.4. And finally, I needed 3 significant figures, so my answer would be 9.4.
Can you spell that?
Right, now, I do want to draw your attention to something, ladies and gentlemen. We have just discussed that in detail, but what I'm going to do is I'm going to take this bit here and what we ended up with, all right? And I'm going to ask you to look at something and go, ooh, actually, I could probably do this really quickly and easily. So I'm going to look at that, and I'm going to look at this one before we actually work it out. Okay? So I'm going to write that here in this space. So let's compare x equals 5 divided by 0.5299 and compare that to 0.5299 equals 5 divided by x. So looking at, let's get rid of that green dot. Looking at those two things, let me just take the answer out of the way just for now. Looking at those two things, could you see a potential shortcut? Do you want to see that? See what he said? What did he say? Yeah. Do you want to spot that? So this process, now I think it's super important that we talk through this process about why it happens and how it happens. But just from a visual perspective, in this case, if the unknown, if the thing I want is actually the denominator or the divisor, all right? When I do all that rearrangement, it ends up here, right? And what was the numerator here ends up as the denominator, okay? So it looks like all they do is swap positions. I don't like saying they swap positions because there's actually a mathematical reasoning behind it. But it could help us with our methods, right? So with the unknown, so Sienna, when you tried to move the 5 and just get rid of it, well, it wasn't the 5 that we wanted to move, it was the x and, yeah, exactly. So that could be a little bit, hopefully you'll understand why, but if you can't remember all of that process, maybe a minimum, remember that if the unknown is what you divide by, you can swap it around. Well, you can, yes, you can, but remember most of the stuff, all the other ones, the x is the x on top, and all right. So let's just see. Let me try and find.